So today we're actually going to be multiplying two matrices together. Now, when we look over what we've done, we've gone over what the dot product is, and we've gone over the fact that the matrices have to line up in such a way that their elements, each element of the first row must match up with an element of the second one's columns in order to take that dot product. We also know that they will produce a matrix that may be larger or smaller than the original two, in which case this will be a 3 by 3 matrix. The number of rows in the first and the number of columns in the second will be the resulting matrix. But as long as I have a 2 by 2 match, I'm good. So let's go ahead and let's walk through one of the guided examples. In this case, we have two given matrices. We're going to check to make sure these two are compatible, which we've just gone through they are. This is a 3 by 2, and this one is a 2 by 3. We know the fact that the two matrices check out. They are compatible to find the dot product, and they're going to produce a 3 by 3 matrix. So now what we're going to do is we're going to go ahead and we're going to circle the row and the column as you find the dot product of each combination. One of the ways that we're going to get started with this is it's going to be helpful to say, hey, if I have a 2 by 4, 6 by 8, 10 by 12, 3, 6, 9, 2, 4, 6, is we are going to be multiplying this row by this column. Now, if this is the first row and the first column, whatever the dot product of this is going to give me my first aspect up here. So I have a 2 by 3 plus a 4 by 2 up in the first entry. Now, when I take this and I multiply it times the second one, let's do this in, let's just say red, I'll have a 2 by 6 plus a 4 by 4 in my second entry. And in my third one, I'll have a 2 by 9 and a 4 by 6. Now, in all reality, there's not going to be enough room to work this out, but we know that the first row of my two matrices is going to give me three different values. My first row, 2 by 3 plus 4 by 2, that's 6 plus 8. It's going to be 14. The next element of my top row is going to be 12 plus 16, which is 28. The last element of my top row is going to be 18 plus 24. That's going to be 34, 42. And we're going to do that all the way down. So that's just the first row distributed via the dot product to column 1, 2, and 3. We'd do the same thing to row 2, and we'd produce a second set of numbers, and the same thing to row 3 to produce a third set of numbers. And that's all we're going to be doing today. So without further ado, let's jump into something that's going to have a little bit more tangibleness to it. So for this, we always like to check. We have in this case, a 1 by 2. In this case, we have a 2 by 1. What we notice is that our inside numbers are going to match up. So we can take the dot product, and I'm going to end up producing a 1 by 1 matrix. So let's go ahead and find the first dot product. Now, the first dot product, let's do this in red and this one in blue. So each element of the row, I'm going to have a 2 and a 3, and I'm multiplying it times the -5 and the 2. And I'm going to take those numbers and I'm going to add them together. So 2 times -5 is -10 plus 6. This is a -4. And that is my entire answer. It got reduced down to a 1 by 1 matrix. If I look at the next one, a very similar setup is going to happen. In this case, I have a 1 by 3 and a 3 by 1. Now, I know that the inside elements match up, meaning if I take 1, 2, 3 elements, I match up with 1, 2, 3 elements in the column. and I'm going to end up producing a 1 by 1 matrix. So if I call this A and I call this B, I'm going to have a 6, a 1, and a negative 4. And I'm going to multiply those times a 2, times a 3, and times a 5. Once I've done that, I'm going to add them all together to get my singular entry in this matrix. So 12 plus 3 minus 20, 15 minus 20, that is a negative 5. That is my entire matrix. The last problem on the front is one that's actually going to produce something that's more than a 1 by 1 matrix. This is a 2 by 2, and this is a 2 by 2. We know that the rows will match up with the columns because they have 2 elements and 2 elements. But now this, I will get a 2 by 2 matrix as my answer. So what we're going to be doing most of today on this lesson is I'm going to have 1, 2, 3, 4 answers. I'm going to bust out a second sheet of paper just as scratch to keep all of this work settled in. Okay, so for the first element, I'm going to draw this a little exaggerated just so we can get the idea. I'm going to take the first row in the first column, which means first row, first column of my matrix. We've been doing this as an A and this as a B, which means first row is going to be 2 and a 6 times first column, which is going to be times 8 and times 11. And we're going to add these up. 2 times 8 is going to give me 16 plus 66. This is going to be, let's see, 76 plus 82. There we go. So 82 is going to be what goes in my matrix. Now the other thing that you'll notice where we can kind of flesh out most of this real quickly is I can take my first row and put it over here as well. So I'll have a 2 and a 6 for this entry. For the bottom entry, I'm going to be multiplying the negative 1 and the 0 across this entire row. So the 2 and the 6 on this row, the negative 1 and the 0 on this row. For the first column, everything in my first column is going to be multiplied times 8 and 11. So 8 and 11, 8 and 11. And when I move over to my second column, I move over to the second column of the second matrix. This is going to be times negative 7, and 10, negative 7, and 10. Boom. And we can actually verify that these numbers work if we look at, okay, so of my new answer matrix, this is going to be the second row, let's say row 2, and column 2. So I should be looking at row 2, which is the negative 1 and the 0, and column 2, which is going to be the negative 7 and the 10. So boom, I know that that's going to work out. That's going to give me a negative 8 plus 0, negative 8. Negative 14 and 60 is going to give me, let's see, 50 and 46. That's going to give me a 7 plus 0, or a 7. So now I know what my resulting matrix is going to be. My answer for this, when I multiply this matrix times this matrix, is going to be 82, 46, negative 8, and 7. And there we go. So now that we've seen one of those, let's try one again. Let's see a second problem that takes up that same style work. Okay, so let's look at number 7. Okay, so number 7, I'm going to pair these up and I'm going to say, okay, row and column. It looks like it's good. I have a 2 by 2 and a 2 by 2. They match up. I'm going to get a 2 by 2, which means that what I might as well try and do is set this up. I'm going to get a 2 by 2 matrix. Now, I can fill this out as we've been doing, where I say, okay, this is going to have a 3 and a -2, and it's going to be multiplied times the 4 and the 9. But another way that we can do it is similar to what we did in the last one. This is row 1, column 1 of my answer matrix, of my answer. This is row 1, column 2. This is row 2, column 1. And this is row 2, column 2. Those are going to be the aspects that I take from the first matrix and the second matrix on every single one of these answer grids. So if I do an A and a B, let's go ahead and pop in our work here. So for row 1, I have a 3 and a -2. So now here I'm going to have a 3 and a -2, and here I'm going to have a 3 and a -2. Row 2 is going to have a 1 and an 8, a 1 and an 8. For column 1, I'm going to have a 4 and a 9 on both the top and the bottom, because this is all the same column. Second column is going to be a 5 and a 12. A 5 and a 12 on the top and the bottom. And then all I need to do is figure out what the sum of both of those are. So 12 minus 18, -6. 15 minus 24, -9. 4 plus 72, 76. 5 plus, let's see, that's 80 plus 16, 96. It's going to be 101. So my answer to number 7 is going to be -6, -9, 76, 101. Boom. There we go. So now that you've seen that, why don't you go ahead and try number 9 and number 11 on your own. Unpause the video when you're done and see how well you did. Okay. So now that you've had a chance to work this, let's go ahead and take a look and see how well we're doing. I know these are both going to be row 1. This is both going to be row 2 and row 2. I have right here column 1, and then over here I have column 2. I know I have my A and my B. I probably should have checked to make sure this works, but we know that the 2 by 2 and a 2 by 2, no matter which order they're going in, this is going to work. It matches up, and I'm going to produce a 2 by 2. So for row 1, I have a 3 and a 12, a 3 and a 12. Row 2, I have a 10 and a -1. For column 1, I have a -2 and a 3, a -2 and a 3. Column 2, I have a 0 and a 9, a 0 and a 9. I'm going to be finding the dot product of each of these. So -6 plus 36 is 30. 0 plus, let's see, that's 90 plus 18 is 108. -20 minus 3 is -23. 0 minus 9 is -9. So now my answer for number 9 is going to be 30, 108, -23, -9. Boom. There we go. And so if you tried number 11, we noticed that this thing is popping up again. We've talked about this previously. This is the identity matrix. We're going to see what happens when I multiply a matrix times the identity matrix. So if we went ahead and we started on number 11, again, we can check this 2 by 2, 2 by 2. I noticed that my columns, row by column, so my columns match the rows, so everything's good. I'm going to end up producing a 2 by 2 matrix. So if I know I'm going to produce a 2 by 2 matrix, what I'm going to do over here is I'm going to produce a 2 by 2 grid to work my answers. And I'm going to label this, both of these are row 1, both of these are row 2. This is column 1, and this is column 2. And then I'm just going to fill in what information I know. A and B. So row 1, 1, 0, 1, 0. Row 2, 0, 1, 0, 1. Column 1, -6 and 15, -6 and 15. Move over to column 2, 5, -7, 5, -7. We're going to find the dot product of each one of these. So -6 plus 0, 5 plus 0, 0 plus 15, 0 plus a -7, which is -7. So what we get is a -6, 5, 15, and -7. Okay, so what did you notice when you multiplied this matrix times the dot product? Or not times the dot product, times the identity matrix. It's called an identity matrix because when you multiply this matrix times any other matrix that it's compatible with, you get back the same matrix. So the identity means that when I multiply these two matrices together, nothing changes. I get back my same matrix in the same way that if I multiplied, let's say just the 1 times the -6, 1 would be the identity coefficient because 1 times -6 is -6. I would get back my original answer. So let's pop off to something that's a little bigger. So with this one, I have 3 rows and 2 columns, 2 rows and 3 columns. What I notice is that my dot product is compatible, but I will produce a 3 by 3 matrix. So on my little scratch sheet, I'm going to have to give myself a little more room. So number 13, I'm going to create enough space. Boom. Just going to move over for this. I'm going to have a three by 3. I hope this is enough room. So I'm going to go through and I'm going to label my rows. Row 1, row 1, row 1, row 2, row 2, row 2, row 3, row 3, row 3. Then I'm going to go down my columns, column 1, column 2, and column 3. So we're finding the dot product of those 9 pieces. Again, we label our matrices as we've been doing, as an A and a B. This should make this pretty easy to set up. So for all of row 1, I'm going to put in my 2 values for row 1, 1 and 4. For row 2, I'm going to plug in 8 and -2. And for row 3, a 7 and a -14. Might not have given myself enough space to work these, but oh well, it's too late. For column 1, I'm going to plug in 6 and 3 for all of these. So I get 8 times 6 times 3 times 6 times 3 times 6 times 3. For the next column, -1 and -4. Awesome. And for the last column, I'm going to get a 0 and a 1. Awesome. And then I'm going to go through and find the dot product of each one of these, or find the sum of the 2 products. So for my first one, I'll get 6 plus 12, which is 18. -1 minus 16, which is -17. I'll get 0 plus 4. I will get let's see, that is 48 minus 6, which is 42. Negative 8 plus 8. 0 minus 2. 42. My own handwriting, I can't read it. Let's see, row 3, 7 and negative 14. Column 1, 6 and a 3. So 14 times 3, that's going to be 30, 42. Negative 7, that's going to be a 40, 56. Zero minus 14, negative 14. Perfect. And then this is all the information I need to actually make my matrix. So I know it's going to be a 3 by 3, 18, negative 17, and 4, 42, 0, and negative 2, 0, 49, and negative 14. Boom. And there we go. So why don't you go ahead and try the next two. We have 2 left. I have numbers 15 and number 17. Pause the video, give them a shot, and see how well you do. Unpause it when you're done and check your work. Okay, so now that you've had a minute, let's go ahead and let's break out. I'm going to break out a new sheet right now. What I notice is that I have 3 by 3s on both of them. So I know they're compatible and I know what the dimensions are going to be. Because when we have square matrices, I'm going to produce a matrix that's exactly the same. They're compatible, and I'll produce a 3 by 3. So what I'm going to do this time on number 15 is I'm going to give myself a little bit more space. Yeah. I'm going to say that much space, that much space. There we go. Okay. Now I am aware this is taking up a lot of scratch space. Again, most of these you don't really need to worry too much about, because some of these you can just do in your head, but we're showing all of our work going on right now. So I have row 1, row 2, and row 3. I have column 1, column 2, and column 3. If I label these like I've been labeling them, with an A, with an A and a B, I guess we can go ahead and label this B because we're going to do that next. If I have an A and a B, I'm going to go through, I'm going to put row 1, a 1, a 3, and a 5 in each one of these. So I have a 1, a 3, and a 5. I'm going to put a 7, 9, and 11 in all of row 2. I'm going to put a 13, 15, and 17. In row 3. Next, I'm going to put column 1 in all of column 1, so 0, 6, and 12. So 0, 6, and 12. I'm going to put a 2, an 8, and a 14 in all of column 2. So a 2, an 8, and a 14 in column 2. I'm going to put a 4, a 10, and a 16 in column 3. Awesome. And so now, the hard part was setting it up. The easy part is just going ahead and adding all of these together. And and quite possibly because we did this rather quickly, is attempting to read our own handwriting. So 1 and 0 plus 18 plus 60 is going to give us a 78. 2 plus 24 plus 70, that's going to be 94, 96. Let's see, that's 50 plus 30, 80, that's 110, 114. 0 plus 54, 11 and 12 is going to make, let's see, 144. It's going to be 132. It's going to make 136, 186. Row 2, column 2, so that's going to be 7, 9, and 11, 2, 8, and 14. Okay. 14, 72. It's 140 plus 14. That's going to be 154. This will be fun. 156 plus 70 is going to be 226. Plus 14 is going to be 230, 240. You might want to double check my work here because I may make an arithmetic error. Gotta try not to. 28 plus 90 plus 176. That's going to be 266, 286, 294. Let's see, that's going to be 60 plus 30 is 90. It's going to be 170 plus 34, so 204, 294, 26. Let's see, 10 times 8 is 80, plus 40 is 120. Let's see, 17 times 14. Okay, so this one's going to be 170 plus, let's see, that'll be 34, 68, 170 plus 68 is 238. It's going to be 146. Actually, we're going to add it this way. It's going to be 358, 378, 384. Let's see, 13 times 4, that's going to be 40 plus 12. $17 and 16. Okay, so we've got, let's just say 16 squared. 16 squared is going to be 256. 256 plus another 16 is going to be 266, 272. It's going to be 322, 422, 472, 474. Boom. After much deliberation, we've got our final answer for our matrix. This is going to be a 3 by 3. Okay, so we got 78, 96, and 114. 186, 240, 294, 294, 384, and 474. Boom. There we go. There's our answer. Okay, so we see that we went through a lot of work for that one. We set up several different examples. None of this is extremely difficult. This is just a lot of arithmetic going on here. So if you check your work for number 17, you could have done it the long way and set up the entire grid, but what you could have noticed is that what we have going on here is our identity matrix. So we know that what we're going to be dealing with is if I multiply my identity matrix times this matrix, I'm going to get this matrix back. So I don't actually need to show any work on this last one. This last one's going to give us a 20, negative 13, 17, 55, negative 64, 15, 72, 55, and negative 8. And that is going to be our answer. And you can always double check this because I know the first row in the first column, the 2 zeros are going to zero out my last two terms. The only number that's going to make it through is my 20. If I move to the second column, my 20 and my 17 are going to cancel out, and the only thing that's going to be left is going to be my negative 13. And then I have to do my row times the last column. The only thing that's going to survive is the last element, which is why the 17 survives. But that's how we multiply two matrices together. There we go.